guys, and welcome back to Maths with Cats. So today we're going to be going over angles, arc length and sector area for AQA A-Level Maths. So first thing you need to understand for this topic is what's the difference between radians and degrees. Radians, like degrees, are ways of measuring angles. 180 degrees is equal to pi radians. To convert from radians to degrees, you divide by pi and multiply by 180. To convert from degrees to radians, you divide by 180 and multiply by pi. Common angles in degrees and radians. So these are useful to learn. However, you have a calculator in all your A-level exams, so it's not the end of the world if you just have to type it in on your calculator quickly. But 0 degrees is 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. 90 equals pi over 2. 120 is equal to 2 pi over 3. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. Now, I basically used the 180 equals pi to remember how to convert. Because if I know 180 is equal to pi radians, and I want to know how many radians is equivalent to 30 degrees, I'm going to divide by 6. And then we would get the answer. Okay, sector. You should know this from GCSE, but it's useful to know. Sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan is equal to sine over cos, which is opposite over adjacent. Some trig values that are useful to know. Should know them in both degrees and radians at A-level. Again, you have a calculator, so supposed to learn them off by heart, but they don't know if you've used a calculator or not. Sine 30 is the same as sine of pi over 6 radians, which is a half. Cos 30 or cos pi over 6 radians is root 3 over 2. Tan 30 or tan of pi over 6 radians is 1 over root 3. Sine 60 is equal to sine pi over 3 radians, which is equal to root 3 over 2. Cos 60 is equal to cos pi over 3 radians, which is equal to a half. And tan 60 is equal to tan of pi over 3 radians, which is equal to root 3. Next up, sine 45 is equal to sine of pi over 4 radians, which is equal to 1 over root 2. Cos of 45 or pi over 4 radians is 1 over root 2. Oh, I'm not sure if that's right or not. It might be actually. Let me double check. I've got my calculator here. Cos 45. Oh, it's in radians. Cos of pi over 4 root 2 over 2, which is the same. It's just been rationalised. Sorry about that. Tan 45 is equal to tan of pi over 4, which equals 1. Now, you just heard I used my calculator in radians. How do you do that? So if you're on a Casio class whiz, you can just press Shift and then the menu button, which is next to the on button. Go to angle unit, which is number 2. And then if you want degrees, you press number 1. If you want radians, you press number 2. We don't use gradients. Okay, now we'll get on to lengths, arcs, and area of sectors. So this bit is an arc. Sometimes it will ask for a length for this bit. As you can see, it is going to be a certain fraction of the circumference. How do you know what the fraction is? Well, it's going to be this divided by this entire angle and in degrees, it's going to be theta over 360, lots of the circumference. And in radians, it's going to be theta over 2 pi, lots of the circumference. This bit is the radius, you know what that is. This entire thing here is sector, so if you find the area, you find this entire kind of cheese slice, which is again going to be this fraction of the entire area of a circle. So in degrees, the arc length can be calculated using theta over 360 lots of pi d, theta over 360 lots of the circumference. In radians, it will be theta over 2 pi lots of pi d circumference. But you can see this can be simplified to theta over 2 lots of 2r, which can be simplified again. So basically what we've done here is we've cancelled out the pi and we've made the d a 2r because there's 2 lots of radius. So we have theta over 2 lots of 2r, which can be simplified again to cancel out the 2's, so you end up with r theta. So a lot of people choose, even if it's been given in degrees, use this one instead because it's simpler. It's just whether your conversion is strong enough for that to be easier. So that's for you to figure out. In degrees, the area of a sector can be calculated using theta over 360 lots of pi r squared, a fraction of the area. In radians, it becomes theta over 2 pi lots of pi r squared. The pi can cancel out and you get half r squared theta. That's as simple as it gets. But once again, it's simpler than the one for degrees, so it might be easier for you. It might be easier to just leave it as it is. It's up to you. Okay, now we get on to some examples. Find the exact length L and area A in the diagram. Okay, so the length L is the arc length here, and the area A is the area of the sector. So we can either work in degrees or convert to radians. I'm going to show you how to do both. So in degrees, arc length is going to be 45, because that's the degrees at the centre, over 360, lots of pi, lots of 2, lots of 20, which is going to be 5 pi centimetres. So the 2 is part of the formula. The 20 is the radius. Okay, so for the area, if you work in degrees, 45 out of 360, lots of pi, lots of 20 squared, because 20 is the radius, which gives us 50 pi centimetres squared. If you think it's easier, you can convert to radians and then work them out from there. So 45 degrees is 45 pi over 180 radians, which is going to be pi over 4 radians. Arc length is going to be 20 radius, lots of pi over 4 angle, which is 5 pi centimetres. And the area is going to be half of 20 squared, r squared, lots of pi over 4 theta, which is 50 pi centimetres squared. So both of them work, completely up to you which you choose to use. Some more examples. Find the area of the shaded part of the diagram. So you're going to find the red parts. The area of one sector, so let's say this one, is going to be half, lots of 10 squared radius, lots of pi over 4 theta, which is 25 pi over 2 centimetres squared. We have 4, so we're going to do 4 lots of that, which is 50 pi centimetres squared. So that's the end of the video. I know there weren't very many examples in there, but there's not really much content. That's basically it. If you have any feedback, leave it in the comments below. Don't forget to like, share, subscribe, and I will hopefully see you in a future video. Bye bye!